Hello, I recently put this tool together for a friend of mine and I figured it would be valuable enough to share. So this is available as a Google Doc template. The link is below. And it's basically plug and play and you can use it yourself, or you can just deconstruct it and rebuild it to better fit your business. So basically there are three models here to help with scheduling. The first is a queuing model, and what this answers is, how many people do I need on staff at one time to handle volumes? Everything here is just dummy data. You would need to use data from your business or your operation. The next model is a linear optimization model, which answers the question that says, okay, we now know how many people are here. How do we do it cost effectively? And then the third tool is really these three tools together. The scheduler, actually how you put people in place, how you place them on the schedule. So very quickly I'll walk through this again. This is available as a template and you can play around with any of the cells that have colors like this, and I've included additional resources. So the first tool is the queuing model, and what this does is basically answers, given your volume at certain hours of the day, how many people do you need on staff to meet your service levels, and here are your service levels. And this is set up in what's called an MMN model, and that's basically like a bank teller where you go into a single file line and go to the next available teller. So diving in here, you put your transactions here, whether it's customers or transactions or widgets, whatever it is, and then what I've done is do it across the day. So these are just the hours in the day, and this was based on a study, so you'd have to study your traffic and understand at what time of the day do you get a certain percentage of traffic. So for example, at 3 in the morning in this dummy data there's 0.43% of traffic, whereas at noon there's 7% of traffic. So it's 7% of the 1,000. So what you have to first do is convert that into on a minute basis. So essentially every minute during this period, 0.4 customers come in. So at midnight, every minute you'll see 0.4 customers. So that means that you're not even going to see one customer in per minute. Whereas when you come over here, you start to see, every minute you're going to have more than one customer. So again, what you need to do is understand your total transactions, total traffic, put it out on the day by the percentage, and then it will calculate here what the number of tickets arriving are per minute. So then what we have to do is calculate the number of staff members we need, and this is driven by our service levels. So what this does is say, if we have a goal time of somebody being in the system for 5 minutes, and they are and it takes 3 minutes to service that person, how many people do we need for every 0.22 minutes coming, for a customer coming in every 0.22 minutes. So again, so this is essentially saying that it takes 3 minutes to service a customer, produce a widget, whatever it is, and that you want that widget or customer to be out of the system in 5 minutes total, which basically means that they are waiting in line for 2 minutes. 2 minutes plus the 3 minute service time equals 5 minutes in the system. So this is already all done, and you can see that with 1,000 transactions, you want somebody out of the system for 5 minutes, and it takes you 3 minutes to service them. At noon, you need 9 people. Well, let's just say that you want the goal time to increase to 10 minutes, which basically means you're lowering your service levels because you're okay with somebody waiting in line for 10 minutes. Obviously, that's going to drive down the total number of people you need, so that brings it down to 5 at this time. And now let's go and say, let's bring it back. It was 5. Let's say what happens if we want to do it in 4 minutes, and it drastically increases. It goes back up to 14. So again, you can just play with this and say, you know what, I actually need 10,000 at 4, and you can see like, wow, you need 137 people. But if you increase your goal time to 20 minutes, you're back down to 41. So this is the queuing model. Essentially says how many people you need over a period of time. So the next thing is the linear optimization model. And what this does is say, okay, we now know what we need over time, but what's the most cost-effective way to do this? So there's a lot going on here. Here's a resource. I actually learned this from somebody, and it is very valuable. This is the original source I learned it from. But basically, shifts have different costs. Again, this is dummy data, but you would be able to have good insights into what your costs are per shift. Overnight's probably more. Maybe your peak time also costs more because you want your best people there. And then it just basically says, here's the shift, and here's the 2-hour increments that these people work. And the idea is that for these 2-hour increments, you need to have this minimum amount of coverage. And this will make sense once I do a solver. So we're trying to solve for the total cost. We're trying to minimize the total cost by changing the number of people working. So we come to the solver, and we've already selected F16. So we just want to optimize on minimizing. So we want to minimize F16. And we want to do that by changing the number of people working on these shifts. So come in here and write E16. And I'm restricting it to be greater than or equal to 0 because you can't have negative people. So now we have a bunch of conditions that need to be met, and those are basically saying that the total number of people working has to be greater than or equal to the minimum number required. So we have to do that for every single one of these. And it takes a little time, so I'm going to actually pause the video. So we've put in all the conditions. Basically, total working has to be greater than or equal to the minimum. So when I hit solve here, basically Google Docs is going to run a bunch of calculations very quickly and optimize on the best scenario to give us the lowest cost. And the lowest cost is being calculated by number of working times the cost per shift. So if I hit solve, there you go. So essentially it's saying that we need 5 people in the 8 a.m., 7 on the 10 p.m., 0 on the 2 p.m. because that's the most expensive, and then we'll bulk up on the 4 to midnight because even though we will have excess people here, we'll have 12 people working when you only need 4, it's better to have them there than a lot of people at the from the 2 p.m. shift. So again, all dummy data, but very valuable tool when you start to plug this in yourself. And of course, these are all interchangeable. So then the final thing is the scheduler. So we've done the queuing model, which tells us how many people we need. We've done the linear optimization tool, which tells us the shifts that we should be putting people on. And then you actually need a schedule to build and publish for people. So in the schedule, essentially grab it and use it yourself. You can change these names over on the list tab. But basically, as long as this is green, the row is green, and the column is green, column and row are green, you can change it. So this is changeable, but you can't change this. So basically go through this and fill in the team members. So for example, just say that this is Judy, who's SD, which is a role, and working Tuesday through Saturday. And you fill all of this in with your team members. When you come in here, you just put in the date for Monday. So this is a flexible thing. So 3/17 makes this grow by the week. If I come here and make it 3/18, even though that's on a Monday, you see that these rows change. So fill this in based on what you need from people's day off requests, people's time off requests and what you learn from the queuing model and the linear optimization model, and start to build this out. And what it tells you is, okay, here's the estimated number that that person will work, and then if you come down here, it starts to tell you smart data about total hours in the day, per day, a little bit of a graph to help you visualize it, and then an estimated cost for the week. And this is a fill rate. 95.95 fill rate means if you schedule 100 hours, expect 95 hours because there's lateness, there's sickness. Maybe you can let people go early that week. And then your average hourly cost, again, all dummy data. And then over here, I've just basically reversed the schedule, and this is just so you have something nicer to print, because people just want to see their name across. They don't want to see this view where it's Judy mid to 8 on that day. They just want to see mid to 8 and here's Judy, here's my name. So build that out, and then this is where this becomes really powerful, is you can come to this visualization and you can see on a per day basis what your coverage looks like. So you would just kind of go through and change this and say, okay, that looks good, and you're comparing it to what you see in your queuing model. So okay, that starts to look right based on what we have. And then you can go even into more details and say, okay, what I'm curious about is, what does the operation of queue look like on this day versus SD for this day. And you can start to get more granular into it. And as you can see, there's fewer SDs than queue. So see if CC has a role, so there's no one scheduled for CC. Back to queue, and you can see it for that Tuesday. And now for that Friday. So again, this is a pretty robust tool. Answers with the queuing model, how many you need per hour based on your service levels and volumes. Linear optimization helps you understand the best way to reduce costs. And then you have your scheduling tool, which actually helps you put people in place, and you can start to visualize those over hour, day, and by task. Thank you. Have a great day. And if you need anything, you can always reach out to me. My blog is jonathansteinman.com. Thank you.